All right, let's talk about something truly wild. Imagine a massive machine, a mechanical marvel, being built deep inside a mountain. It's not a secret base, it's not a doomsday device, it's a clock. But this is not just any clock. This thing is being engineered to keep accurate time for the next 10,000 years.
Yeah, you heard that right. 10,000 years. Just let that number sink in for a second. That's a span of time that reaches all the way back to the dawn of human civilization and all the way forward into a future that's almost impossible to even picture. This is about so much more than telling time. It's about trying to completely change how we think about time itself.
And this is the vision that kicked the whole thing off. This quote is from the inventor, Danny Hillis, way back in 1995. I mean, come on. A cuckoo that comes out once every 1,000 years, that tells you everything. This was never just about a timepiece. It's a statement. It's a challenge for us to think on a scale that's, well, almost mythical.
So that brings us to the big question. Why, right? Why on earth would anyone build a machine that's designed to outlast our entire civilization? What is the big idea behind something this monumental?
Well, the answer is all about this idea called the long now. You see, most of us live in the short now. We're all about the next news alert, the next quarterly report, the next election cycle. The clock is meant to be the opposite. It's a physical, tangible anchor for thinking in the long now, a way to encourage us to think about our responsibilities to the generations that will come long, long after us.
And this is just the perfect analogy for what the clock is trying to do. It's from Stuart Brandt, one of the founders of the Long Now Foundation. You know that famous blue marble photo of Earth from space? How it totally changed how we felt about protecting our planet? That is the goal here. The clock is supposed to be that for time, an icon that completely reframes our perspective.
And all this really gets to the core philosophy of the project. It's this idea of thinking in deep time. It's about trying to fundamentally shift our relationship with the future. So the plan isn't for this thing to be some obscure technical marvel hidden away forever. No way. The whole point is for it to be a cultural landmark, something people will want to visit, something to think about, something to talk about. It's basically a giant conversation starter designed to be so cool that it forces the idea of long-term thinking into our daily lives.
Of course, if you're going to build something that lasts 10,000 years, you're going to run into a few unique engineering problems. So to even get started, the team laid out 5 core design principles. Basically, they're rules for how to build forever. And what's so brilliant about these rules is how practical they are. First, longevity. It has to last and it has to be made of materials that aren't valuable enough to be looted. Then, maintainability. Future generations have to be able to fix it, even if all they have are, say, Bronze Age tools. Third, transparency. You should be able to understand how it works just by looking at it, no black boxes. Fourth, evolvability. It needs to be possible to improve it over time. And finally, scalability. They had to build prototypes first to prove the big one would even work.
All right, so those are the rules. Now for the really fun part. How do they actually solve these massive engineering puzzles? Let's geek out for a minute on how this clock is being built for the ages.
First problem, how do you power it? The main power source is beautifully simple. It's us. Visitors will literally wind the clock. But what if nobody shows up for 100 years? Well, it has a backup. It uses the temperature difference between the hot desert day and the cold night to capture a tiny amount of thermal energy. It's just enough to keep the clock's heart beating, even if it's completely abandoned.
The next problem was even harder. How do you keep it accurate? A normal pendulum would wear down and drift. An atomic clock is a complete black box. That breaks the transparency rule. And just using the sun is great, until it gets cloudy. That's just not reliable enough. The solution they came up with is this absolutely ingenious 2-part system. The first part is a big, rugged mechanical oscillator. Now, it's not perfectly accurate, but it is incredibly reliable. It's designed to just keep ticking, no matter what.
Part 2 is all about accuracy. On any clear day, right at solar noon, a lens focuses sunlight onto a piece of metal, which heats up and buckles. That physical action resets the clock to the exact right time. It's perfectly accurate, but totally unreliable because, weather.
And here's where the magic happens. The two systems work together. The reliable part just chugs along, keeping the time. And then on every sunny day, that super accurate solar event happens and basically tunes it, correcting any tiny drift. It's like a musician with perfect rhythm who occasionally checks a tuning fork to make sure they're still in key. It combines the best of both worlds, reliability and accuracy.
Now, a normal clock uses gears to calculate the date, but over thousands of years, even the smallest error in a gear ratio would become a huge problem. So the 10,000-year clock doesn't use gears for that. Instead, its brain is a 32-bit mechanical computer made out of levers and pins that does its calculations in binary.
And this is a really big deal. Here's a mind-bending fact. The Earth's rotation is actually slowing down, but not at a rate we can perfectly predict. For a gear-based clock, that would be a fatal flaw. But because this is a mechanical computer, future generations can actually adjust the calculations to account for the longer day, all without ever stopping the clock. It's designed to be updated.
So we've got the philosophy and the incredible engineering. Now let's talk about the clock as an actual object, this monument in a mountain that's being built as a symbol for the future.
So what will you actually see if you visit? Well, it displays time on multiple scales. There's a star field that shows the 26,000-year wobble of the Earth's axis. There are dials for the sun and the moon. And for us, there's a display for the Gregorian year, but with 5 digits. It'll show 02025, for example, because they're literally planning ahead to avoid a Y10K problem.
And this is not just some idea on a napkin. The first full-scale clock is being built right now with $42 million from Jeff Bezos, deep inside a mountain he owns in Texas. This is the real thing, where they're working out all the kinks.
But that's not its final home. That's already been picked out, a remote mountain in Nevada. And the location is just perfect. It's near a grove of bristlecone pine trees, and some of those trees are already almost 5,000 years old. The clock will sit amongst some of the oldest living things on Earth. And that brings us full circle, right back to that original vision from Stewart Brand. The clock is so much more than its parts. It's a physical, tangible symbol of deep time, engineered to inspire a little bit of awe and make people think for generation after generation after generation.
Which really just leaves us with one final big question. This whole project proves that human beings are capable of planning and building for a 10,000-year future. So, if we can apply this incredible long-term thinking to building a clock, what else could we do? What happens when we take that same long-now perspective and aim it at our biggest challenges? From climate change to space exploration, what else could we achieve?